Hello everyone and welcome back to another session on Rians.org. Today we are going to run through a few problems that have appeared in your previous CBSE papers as well as some other problems on the topic of polynomials. So we've already covered the class on polynomials in the previous session. We've gone through what is the degree of a polynomial, how do you find zeros of a polynomial, what is the value of a polynomial, and then what's the relationship between zeros and coefficients of a quadratic as well as a cubic polynomial. Now we're going to take up a few problems on these topics so that you're more aware of what sort of questions you'd face in the exam. If you have any further questions apart from these that we're going to right now show you, please do feel free to put them in the comment section, and then we will come back and give you further details on that. Maybe we could correspond on that. So without much ado, let's get started. So the first question is this: find the zeros of the polynomial 6x square minus 3 minus 7x and verify the relationship between the zeros and the coefficient. So this is a quadratic polynomial, and we could write this properly as 6x square minus 7x minus 3. So you know that the product of this is 6 3s are 18, which can be also expressed as 18 is 9 2s are 18. And since this is negative, you know that one of the numbers is negative and the other has to be positive, and preferably the bigger number has to be negative and the smaller number has to be positive, so that when you subtract them you get minus 7. So 6 3s are 18. The way you could write 18 is you could write this as a factor of 2 and 9, as a factor of 6 and 3, as a factor of 18 and 1. 18, 2, 9. So that's about it. In different ways. So you could write minus 2 into minus 9 or 2 into minus 9. I mean, things like that. So this is minus 18. So it would be sort of like minus 2 into 9 or 2 into minus 9. It would be minus 6 into 3 or 6 into minus 3. Or it would be minus 18 into 1 or 18 into minus 1. Now if you see, the only number out of this that's going to give us minus 7x is 2 and minus 9. So that could be written as 6x square minus 9x plus 2x minus 3, which is nothing but if I remove 3x from this, I'm going to get 2x minus 3. Right, so this can be solved as this, and since we are finding zeros, this is going to be equal to 0. So x is equal to minus 1 by 3 or minus 3 by 2. Sorry, x is going to be equal to plus 3 by 2. Why is that? If you want me to show an additional step, I'll do that just so that you're a bit clear. Since this is equal to 0, we know either 3x plus 1 is equal to 0 or 2x minus 3 is equal to 0. So x is equal to minus 1 by 3 or x is equal to 3 by 2. Right? So now we know the zeros of the equation. Now the relationship between zeros and the coefficient, this particular equation can also be expressed in the formula by the formula x square minus alpha plus beta x plus alpha beta, in which case alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Now let's try alpha plus beta. Alpha plus beta is equal to minus 1 by 3 plus 3 by 2, which is nothing but minus 2, plus 9 by 6, that is nothing but that's going to be nothing but 7 by 6. Right? And what is minus b by a? Minus b by a is nothing but minus of minus 7 by 6, which is nothing but 7 by 6. So this and this has been now proved to be equal. This is 7 by 6, this is 7 by 6, hence equal. If I had to do this for alpha beta, so that would be alpha beta is equal to minus 1 by 3 into 3 by 2, which is nothing but minus 1 by 2, and c by a is equal to minus 3 by 6, that's going to be minus 1 by 2. Right? So if you see, this number is the same as this number, and therefore you can prove that both the numbers, you've proven the relationship between the 0 and the coefficient. If you go ahead and see the next slide, that's what we've done. We've found the answers as minus 1 by 3 and 3 by 2, and then we have gone ahead and calculated minus b by a and c by a and seen that they are equal. Alright. Now coming to the next question. What's the next question? The problem 2 is this. Obtain the zeros of the polynomial root 3x square minus 8x plus 4 root 3. Alright, so if you see a into b, the value of these two is nothing but 4 into root 3 into root 3, that's 12. And it's positive number, so we know either both are positive or both are negative, so it's 12, right? Now 12 is made up of nothing but 2 6 are 12, 2 3s are 6, 3 1s are 3, alright? And so if you had to get 8, you could write it as either minus 6 plus minus 2, or you could write it as 6 plus 2, but 6 plus 2 is going to be plus 8, so it's going to be minus 6 and minus 2 that you're going to write that as. So root 3x square minus 6x minus 2x plus 4 root 3 is equal to 0, because we're trying to find zeros of the equation. So that's going to be root 3x into x minus 2 root 3, because 2 root 3 into root 3 would be giving you 6, minus 2 into x minus 2 root 3 is equal to 0. That's nothing but root 3x minus 2 into x minus 2 root 3. We have taken this x minus 2 root 3 as common over here, and this we have taken common. Root 3x and minus 2 we have taken over here. So this is equal to x. This can be written as root 3x minus 2 is equal to 0, or x minus 2 root 3 is equal to 0. So x is equal to, take the 2 over there and divide that by root 3, so that's going to be 2 by root 3, or x is equal to 2 root 3. Alright, so now it comes the chances to verify. So these are going to be the zeros of the polynomial. Now we need to verify the relationship between its zeros and coefficients. So for what does the relationship say? For any equation of the form x square minus alpha plus beta x plus alpha beta, what happens? Alpha plus beta is equal to minus b by a, alpha beta is equal to c by a. Alpha plus beta is equal to 2 by root 3 plus 2 root 3. That's nothing but 2 plus 2 root 3 into root 3 is 6 divided by root 3. That's 8 by root 3. Alright. And what is minus b by a? Minus b by a is nothing but minus of minus 8 divided by root 3. That's just 8 by root 3. Alright. So if you see this particular number and this particular number is exactly the same, so that's why that can be proved. Similarly, alpha beta is equal to 2 by root 3 into 2 root 3. That's nothing but 4. C by a is also equal to nothing but 4 root 3 by root 3. So that's also nothing but 4. So if you see, this and this matches, and therefore we've proved that zeros, the relationship between the zeros and coefficients. So we've got the same answer. X is equal to 2 by root 3 into 2 root 3. That's what we've done over here. And if you see over here, what we've done is we have found the sum of the zeros, and that's just the same 4 and minus 8 by root 3. So we have proved this. Alright, if you have at any point of time any questions on any of these problems that we've solved, please pause and take a look at the explanation that I've written over there. It's pretty similar to what I've already done as well, but just because some of you might not be able to get my handwriting, it's written more clearly over here. Alright. Now let's go over to the third problem of the day, problem 3. Problem 3 basically says that if the product of the zeros of the polynomial ax square minus 6x minus 6 is 4, find the value of alpha. So now first let us consider alpha and beta are the roots or zeros of the polynomial. Then product alpha beta is equal to c by a, which is nothing but it's equal to minus 6 by a. But we know alpha beta, they've already mentioned alpha beta is equal to 4. So 4 is equal to minus 6 by a, implying a is equal to minus 3 by 2. Alright, so this is a pretty straightforward problem. That's exactly what we've done over here. We've got a is equal to minus 3 by 2. Minus 3 by 2. Alright, so let's go over to the next problem. That's problem number 4. Problem number 4 states that if one zero of the polynomial a square plus 9x square plus 13x plus 6a is reciprocal of the other, find the values of a. So let's consider alpha is equal to just that, and beta is equal to 1 by alpha, in which case alpha plus beta is going to be alpha plus 1 by alpha is going to be minus b by a. Sorry, let's just write it generically and then we will expand. Minus b by a, that's going to be alpha plus 1 by alpha is equal to minus 13 by a square plus 9, and we'll see how to resolve this. The other form being alpha beta is equal to c by a, that's alpha into 1 by alpha, that's equal to c is 6 by a square plus 9. Hey, that just became very simple because the alpha went away. So let's use this particular equation. A square plus 9 is equal to 6, right? Oh, it's 6a here, 6a. So a square minus 6a plus 9 is equal to 0. This, if you want, can be written as a square minus 3a minus 3a plus 9, because we know that 9 is comprising of only two factors, 3, 3. So it can be written as 3 into 3 or 9 into 1, and we know there's only one number that can give you 6 as minus 6 as its sum, and positive 9 as its product. So that's minus 3 into minus 3. So that's 0. So this can be, again, take out the common factors. We can take a from these two numbers and we can take 3 from these two numbers. So that gives you 0, and this is the same, if you notice, as a minus 3 squared is equal to 0. So there's only a is equal to 3 and a is equal to 3. That's the only value of 0 that's possible. So if you see, that's what we've got over here. A is equal to 3. Alright. So with this, we'll go on to the next problem. Please take a look at this page if you're not very clear with what I've already explained. So you can go a little slowly at your own pace and see whether you've understood this particular problem. Let's go to problem 5. Problem 5 says that find a quadratic polynomial whose zeros are alpha 1 and minus 3. Verify the relationship between the coefficients and the zeros of the polynomial. So let's consider alpha is equal to 1 and beta is equal to minus 3. And such a polynomial can be explained using this formula. Alright, so that is basically your f of x. Alright, so f of x can be also explained as x square minus 1 minus 3 x plus 1 into minus 3. That's nothing but x square plus 2x minus 3. Alright, so now alpha plus beta. If I found alpha plus beta, that's nothing but 1 minus 3 is equal to minus 2. Alright, and normally I need to prove that this is equal to minus b by a, so that's nothing but minus 2 by 1, so that's minus 2. And alpha beta is equal to 1 into minus 3, so that's minus 3, and c by a is nothing but minus 3 by 1, that's minus 3. Hence, we can prove the relationship between the zeros and the coefficients of the polynomial as well. If you see, that's what I have done over here as well. X square plus 2x minus 3 is what we've got, and then this is how we've gone ahead and proved both these values are the same. Alright, so the relationship has been proved over here. Alright, now let's go over to the next problem. That's problem number 6. What is this problem about? So find the zeros of 4x square minus 4x minus 3 and verify the relationship between the zeros and coefficients. So let's write this down. 4x square minus 4x minus 3. Now if you found 4 3s are 12. 12 has few factors. 2 6 are 12, 2 3s are 6, 3 1s are 3. Alright, so you need to find two factors which when multiplied gives you minus 12, but which when subtracted, because they give you minus 12, so it can't be both positive or both negative. So when they're subtracted, they give you minus 4. So for that, the bigger number needs to be negative. And if you see, the only way you could do that is 2 to the 4 into 3, but 4 minus 3 is going to be 1. 3 to the 6 minus 2, that's going to give you 4. So it can be written as 4x square minus 6x plus 2x minus 3 is equal to 0. Take out the common factors. 2x is equal to 2x minus 3 plus 1 into 2x minus 3 is equal to 0. 2x plus 1 into 2x minus 3 is equal to 0, which means 2x plus 1 is equal to 0, or 2x minus 3 is equal to 0, which means x is equal to minus 1 by 2 or 3 by 2. Alright, so these are the zeros. Now, alpha plus beta is equal to minus 1 by 2 plus 3 by 2, which is nothing but 1. Because 2, it's going to be 2 by 2, so that's going to be 1. If I took minus b by a, that would be nothing but minus of minus 4 divided by 4, that's 1. So, alpha plus beta is equal to minus b by a, proved, right? Now, alpha beta is equal to minus 1 by 2 into 3 by 2, which is equal to 3 by 4. So, I've taken basically these zeros over here. Alright, and c by a is equal to minus of, c by a is equal to minus 3 by 4. Hence, we can prove that alpha beta is equal to c by a. So that's what we've gone ahead and proved. Alright. So if you go ahead and see in the next screen, that's what we've done. We've found minus 1 by 2 and 3 by 2. And then we've gone ahead and proved that your so alpha plus beta is equal to 1 and minus b by 1, b by a is also equal to 1. And in this case also, both the relationship between zeros and coefficients stands true. Right? Now that's the solution to this particular problem. Moving ahead to the next problem, that's on problem 7. Find the zeros of 5x square minus 4x minus 8x. That's nothing but 5x square minus 8x minus 4. Write it the right way, because sometimes during stress what happens is during the exam you end up just to save. So quite often I've seen this mistake. We try to save time, we don't rewrite the equation, but when we are copying down minus b by a, we'll end up copying 4 instead of 8 as b, because we know that b comes in the second position. So quite often we do silly mistakes because we don't take that extra 1 second to write down a polynomial or something of that sort. So make sure that the steps are clear so that you have as fewer mistakes as possible trying to retrace and fix your errors. Alright, now find the zeros. So this has to be 0. So this is 5 4s are 20 if you see, and the way you can form 20 is 2 10s are 20, 2 5s are 10, and 5 1s are 5. So it's minus 20. So 1 is positive and 1 is negative, and it has to be adding to give 8. That's the only way you can write that is 5x square minus 10x plus 2x minus 4, because if you wrote it as, say, 2 2s are 4 and 5, subtracting that would give you just 1. But if you wrote that as 5 2s are 10 minus 2, that would give you 8. But since this is minus 8 that we want and this is minus 20, we know 1 is positive and 1 is negative. And since this is minus 8, we know the bigger one has to be negative. So minus 10x plus 2x is equal to 0. Now take out common factors. So that's x minus 2 plus 2x minus 2 is equal to 0, which means 5x plus 2 into x minus 2 is equal to 0, which means x is equal to minus 2 by 5 or 2, right? So these are the zeros of the equation. Now if I had to do alpha plus beta is equal to minus b by a, my alpha plus beta would be equal to minus 2 by 5 plus 2, which is nothing but minus 2 plus 10 by 5 is 8 by 5. Minus b by a is nothing but minus of minus 8 by 5 is equal to 8 by 5. Right? Similarly, if I had to prove alpha beta is equal to c by a, alpha beta is equal to minus 2 into 2 by 5, that's minus 4 by 5. C by a is equal to minus 4 by 5. So that's the same as what's shown over here, and that's how we say that both of them are going to give you the, and that's how we say that both of them are going to give you the same answer. That's what I've done over here as well. You've got the same values, right? Minus 2 by 5 and 2, and that's how we proved that both of them match. All right. So with that, let's go on to the next question that we have. That's problem 8. Now, find the zeros of 2 root 3x square minus 5x plus root 3 and verify the relationship. So, let's write this down first. 2 root 3x square minus 5x plus root 3. If you multiply this 2 root 3 into root 3, you're going to get 2 3s are 6, alright? And both of them are positive, alright? So both of them, so they have to be either positive numbers multiplied with each other or negative numbers multiplied with each other. But only when negative numbers are added, you're going to get a negative number. You're not going to get it when you have a positive number added there. So the roots have got to be, or the values have got to be over here like this. All right, so that's what it's going to be. So if I remove 2, that's going to be if I remove 2x, that's going to be root 3x minus 1 minus root 3, that's going to be x minus root 3. That's going to be root 3x minus 1 is equal to 0. 2x minus root 3 into root 3 x minus 1 is equal to 0. X is equal to root 3 by 2 because, or let's just put one more step for your clear understanding. 2x minus root 3 is equal to 0, or root 3x minus 1 is equal to 0, which means x is equal to root 3 by 2, or x is equal to 1 by root 3. Alright, so this is the solution to this. If I had to find the relationship between zeros and coefficients, how would I write that? Alpha plus beta is equal to minus b by a. Alpha plus beta is equal to root 3 by 2 plus 1 by root 3, which is nothing but 3. Root 3 into root 3 is 3 plus 2 into 1 is 2 divided by 2 root 3. That's nothing but 5 by root 3. Alright, if I took this as minus b by a, that would be minus into minus 5 divided by 2 root 3. That's nothing but 5 by 2 root 3. If I wrote this as alpha beta is equal to c by a, alpha beta would have been equal to root 3 by 2 into 1 by root 3. Root 3 would cancel and you would get 1 by 2. Similarly, c by a would be equal to root 3 by 2 root 3. That would be 1 by 2. Alright, so if you see over here, that's what we've done as well. We have removed, if you go over here and see, that's what we've done. We've got the same solution, 1 by root 3 or root 3 by 2. See? And then we've done the same proof. So if you have any problems understanding this particular section, please pause here and take a chance to look through what's written over here. Moving on to the next problem, that's our problem 9 for the day. This says find a quadratic polynomial, sum of whose zeros is 8 and the product is 12. Find the zeros of the polynomial. So we know that alpha plus beta, that's what's given in the question. Alpha plus beta is equal to 8 and alpha beta is equal to 12. We know any polynomial can be written in the form x squared minus alpha plus beta, x plus alpha beta, which is equal to your f of x, right? So f of x is equal to x squared minus 8x plus 12. Right? So this is going to be a polynomial. Now if you have to find the zeros of the polynomial, you know that there have to be two numbers. So first of all, this is a quadratic polynomial. It can only have two zeros because the number of zeros is dependent on the degree of the polynomial, which we've already covered in a previous session. And another thing that we would do is we know that these two numbers have to be either positive or negative, because when multiplied they give you 12. So they are either both positive or both negative. And we also know that when they're added they give you minus 8, which means they're both negative. Now what sort of numbers are there which when multiplied give you 12 and which when added give you 8? That's 6 and 2, right? 6 2s are 12. So we could always write this as f of x is equal to x squared minus 6x minus 2x plus 12, which is nothing but x into x minus 6 minus 2 into x minus 6 is equal to x minus 2 into x minus 6. We need to find zeros of the polynomial, so we know x minus 2 is equal to 0 or x minus 6 is equal to 0. Therefore, x is equal to 2 or 6. These are the zeros of the polynomial. Alright, it's 2 and 6. If you go ahead and see, that's what we've done in the next session as well. 2 and 6 are the zeros of the polynomial. Alright. So now we can go ahead and find the quadratic polynomial, do the next problem. That's problem number 10. So problem number 10 says if x plus a is a factor of polynomial 2x squared plus 2ax plus 5x plus 10, find the value of a. So first of all, we know if x plus a is a factor of any polynomial, then x is equal to minus a is going to give us a 0 of the polynomial. Now x is equal to minus a, let's put that value in. So that's going to be 2. So let's put that value in 2x squared plus 2ax plus 5x plus 10. So that's going to be 2 into minus a whole square plus 2 into a into minus a plus 5 into minus a plus 10. That's going to be 2a square minus 2a square minus 5a plus 10 is equal to 0, because s plus a is a factor of it, right? So once, just that's what we did in the first chapter. If you remember real numbers, if any number is a factor of some other number, when you divide it, you're just going to get remainder as 0. So that's what it is. It is going to give you 0. The value is going to be 0, and x plus a is a factor, means x is equal to minus a is 0 of the value of the polynomial, which means when you substitute minus a, you're going to get 0. So, and that gives you 5a is equal to 10, which means a is equal to 2. If you go ahead and see, that's what we have done in the next session as well. You get a is equal to 2. What we have done additionally over here is we have gone ahead and tried also solving it another way, whereas we have removed 2x from 2x squared plus 2ax, so you get 2x into x plus a plus 5 into x plus 2, and then we've said 2x plus 5, we've brought that together, and then we've taken x plus a into x plus 2. We know that this is a quadratic equation and it can have only two values or two zeros. So x is equal to minus 5 by 2. If that's 1 0, then the other one has to be such that x plus a is, should be the same as x plus 2, so a has to be 2. Alright, so x is equal to minus 2. That's what you would get as the other value. So that's what we were trying to prove over here. A is equal to 2 can be proved this way as well, and we can find zeros as well this way. But I hope you understood this, and let's go over to the next problem that we have. That's our problem 11. Problem 11 says if the zeros of the polynomial, and that's a cubic polynomial now, x cubed minus 3x squared plus x plus 1 are a minus b, a and a plus b. I think I missed it here. It said find a and b. Alright, so if you remember the cube, what was the formula for the cube? So any cubic polynomial can be written as x cubed minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus alpha gamma x plus alpha beta gamma is equal to f of x. It can be written such that alpha plus beta plus gamma is equal to minus b by a. Alright, alpha beta plus beta gamma plus alpha gamma is equal to c by a, and alpha beta gamma is equal to minus d by a. So this is our formula, if you remember. Alright, so now let's solve this. If you see alpha plus beta plus gamma, now this can be nothing but alpha, you know, a minus b plus a plus b, that's your gamma, is equal to minus of your b is minus 3 divided by 1. So this can be written, your minus b goes off, so this can be written as 3a is equal to 3, so a is equal to 1. Alright, now that's one form. Another form is that says your let's take this one, that's simpler one. Alpha beta gamma is equal to minus d, that's 1 divided by 1, so that's minus 1. Now alpha beta gamma can be written as a minus b into a plus b into a is equal to 1. Alright, or is equal to minus 1. So you know this is going to be a square minus b square is equal to 1 by a. You already know a is equal to 1. So 1 minus b square is equal to 1. B is, so b square is equal to, is equal to minus 1. So that's going to give you 1 plus 1. Take this to the other side. Take this over here. So that's going to give 1 plus 1 is 2 is equal to b square, which means b is equal to plus or minus root 2. Hence, zeros can be written as a minus b, or zeros, is equal to 1, 1 plus root 2, 1 minus root 2. Alright, so that's your zeros. If you go ahead and see, that's what we've done here exactly in the next slide as well. We've got a is equal to 1, and then we've got b is equal to plus or minus root 2, and we've written zeros are, I think so we've covered everything this way. So that is what problem 11 was about. With this, we've come to the end of our CBSE problems on first part of polynomials. Please ask us or visit vyans.org and ask us any further doubts that you might have, or please post comments, share, and share this video with your fellow students, with your friends as well, so that all of you can benefit out of it. And if you have any further questions, please feel free to post comments, and we will get back to you with another video or another explanation that would help you understand it. Keep studying and do well in your exams. Bye bye and have a good day.